and welcome to day 7. You have 2 days left of this unit. We are closing in on the end. We are going to skip the first page of the day 7 and we're going to start right on page 25, looking at quadratic and linear systems. So the first thing I want you to see here is that we have a quadratic and we have a linear function. And we want to solve the following systems algebraically. I'm going to show you algebraically and I'm going to show you actually what it looks like graphically too. But when we solve them, what that means is that we are going to take the y's and set them equal to each other. Well, y equals y doesn't make sense. We're going to set what that is. X squared minus x minus 6 equals 2x minus 2. And when you look at this, it should look very familiar. There's nothing new that you are looking at here. You have an x squared and an x, and you know that when you have an x squared and an x, it's a quadratic. You're solving it. You have to set it equal to 0, factor, or use quadratic formula. And so to set it equal to 0, we are going to subtract 2x, and we're going to add the 2. We'll get equal 0 over there. Negative 3x minus 4. You see a nice quadratic. You think to yourself, factors of 4 that subtract to give you 3. Oh yeah, 1 and 4. And it needs to be negative 3, so we know we're looking at x minus 4, x plus 1 equals 0. And we're going to get x equals 4, x equals negative 1. Now, those are the x values of where those two functions intersect. What we don't have is the y values. And so one of the things that you need to remember is always find the y value. The answer is a coordinate pair. Okay? You need the x and the y. And so what we're going to do to find the y value is we're going to take this equation, because it's easier. You could have taken the other one. You could have taken the quadratic, but we're going to take this. And we're going to plug in 4, because that's our first x value. So 2 times 4 minus 2. We know that's 8 minus 2, so we know y equals 6. Same thing here. Y equals 2 times negative 1, plugging in the x value. Minus 2, we're going to get negative 2 minus 2, we're going to get y to equal negative 4. And so our final answer is not just 4 and negative 1, it is the point 4 comma 6 and negative 4 negative 1. Sorry, that is wrong. Do not listen to me there. I wrote that backwards. Let's try that again. Negative 1 comma negative 4. So what I want to show you is what this looks like on a graph so it makes sense to you. So if we look using Desmos, we have the quadratic function in red, we have the linear function in blue, and if you look right here and click on it, there is one intersection point of negative 1, negative 4, and the second intersection point of 4 comma 6. And that is where the two functions intersect, which means that's where the two solutions are. So graphically, it makes sense. You can always check using your calculator. I highly suggest that. Check using the calculator, using the intersection function, but that is how you can check those solutions to make sure that you have them right, and of course we do right here. Looking at number 2, same idea. You have a quadratic, you have a linear function, solve them. So since they're both set equal to y, we will set the two functions equal. And subtract the x, add the 3. Notice it's the same process that we used before. But what you will see here is the fact that factors of 4 that add to 3. Are there any? No, and so therefore you cannot factor that. There's no factors of 4 that add to 3. So we have to go and use the quadratic formula. Or we could have completed the square, but let's use the quadratic formula. So x equals negative b, 3 plus or minus the square root of b squared minus 4 times 1 all over 2 times 1. I did switch the a and c here. So we're going to get x equals, pause it if I'm going too fast, And so you realize what we get is an imaginary root. And so where are they equal? There are no real solutions. And you can see this in the graph. Notice that you can tell they never intersect. And so, therefore, there are no real solutions. And we know that this is the imaginary roots, but it doesn't really matter. There are no real solutions. Great. Moving on. This is actually incorrect. We should have a circle equation here. It's not a quadratic. So, in this case, I know you haven't seen circles, but the process does not change. Please realize that. We are going to still, in this scenario, solve for y. I'm going to solve for y. You could have solved for x. It does not matter. So y equals 3/4 x. Now that x is really at the top there, so let's rewrite it. 3x over 4. This is what y equals, and here is y. And therefore, what we're going to do is plug that in for y. X squared plus, you have y. I use parentheses. I like parentheses. You should use them too. So right there, x squared plus 3x over 4 squared equals 25. When you square it, it's like 3x over 4 times 3x over 4. So we're going to get x squared plus 9x squared over 16 equals 25. Notice that these are each over 1, and therefore you need to find a common denominator. Well, the common denominator is 16, so I need to multiply this by 16 and this by 16. And so when I get that, I'm going to get 16x squared plus 9x squared equals 25. Oh, sorry, not 25. I've got to do 25 times 16 should equal 400. And therefore, I'm going to combine the common terms. 16x squared and 9x squared is 25x squared equals 400. Just come up over here. When I have just an x squared, I can solve for x squared as I usually would. Divide by 25. So I'm going to get x squared to equal 16. And to get rid of the squared, you have to square root. Now, when you do that, you need to get plus or minus 4. Again, you're not done. You have to find the y value. So I'm just going to write out 4 and negative 4. And then I'm going to plug in to what y is. Well, y equals 3 times 4 over 4, and y equals 3 times negative 4 over 4. Notice that those 4's cancel, and so I'm left with y equals 3. And this cancels to negative 1, so I'm left with y equals negative 3. So my final answer to this is, where are they equal? They are equal at 4, 3 and negative 4, negative 3. So here it is on the graph. Here are your points, 4, 3, and 4, negative 4, and negative 3, exactly like we had. The circle, radius 0, or sorry, center 0, radius 5. We'll get into that next class. So that is where they are equal. The final example is the same idea, except just a little more difficult. Again, this should not say quadratic equation. This should say a circle. We're looking at something that doesn't just have what y equals, so you have to solve for one of these. You can solve for x or y. There's nothing wrong with either way. I don't like the negative y, so I'm going to add y here. I'm going to get x equals 6 plus y. And this idea that 6 plus y is what x is, I'm going to plug that in. This is called substitution. We need to get used to this. We've done it before. You did it as in algebra, and we've done it in this class a few times. So with what x is, I'm going to get 6 plus y. I'm going to square it. Plus y squared equals 26. And I need to expand it. If you don't know how to expand it quickly, you need to go over here and double distribute. Take a minute to do that. You should get 36 plus 12y plus y squared equals 26. Again, all of this is all of that. I'm going to combine like terms, the y squared and y squared. I'm going to write that first because that's how we usually write it. Plus 12y plus 36 equals 26. Well, when I see a y squared and a y, it's just like x squares, except we got to keep them in terms of y. I want to get it equal to 0. I'm going to subtract 26. I get 2y squared plus 12y plus 10 equals 0. And I notice that each are divisible by 2. So I'm going to divide everything by 2 just to make my life simple. And I can do that because it said equal to 0. I'm still dividing 0 by 2, which gives us 0. Just make it a little arrow up here. I'm going to get y squared plus 6y plus 5 equals 0. And I'm going to factor. Factors of 5 that add to 1 are plus 5. And y plus 1 equals 0. And I'm going to get y to equal negative 5, y to equal negative 1. I'm not done. I have to find my x values. So I'm going to just use what my x is. X equals 6 plus y. So x equals 6 plus negative 5. And x equals 6 plus negative 1. I get x to equal 1 here and x to equal 5 here. And so my final answer, make sure that you write the x value first, is 1 comma negative 5 and 5 comma negative 1. And that is it. Those are the answers, x comma y. And there's nothing really new to this except the substitution aspect. And we've done that before. So again, this combines substitution, expanding using the 6 plus y squared, solving quadratics. You can factor it. You can solve it by using quadratic formula. The idea of imaginary roots come in when there is zero intersection points. And so we're trying to put it all together with this. With that, I will see you in class to talk about circles and the equation of circles. And then we are getting near the end. Have a good day.